Now this week we're going to start on something called factoring. And with factoring, a main skill that you need is to be able to find the greatest common factor. All right, GCF stands for greatest common factor. And there's really two parts to it, to each term that we're going to be looking at. And you're going to get used to looking at polynomials and separating out the terms and examining each term and saying, okay, what's the greatest common factor of each term, and go from there. All right, so the first thing you do is you find the greatest common factor of the coefficients. Those are usually the numbers that are in front of variables. Sometimes they're just numbers that are by themselves. All right, so when we say we're going to find the greatest common factor of the coefficients, that means it's the largest number you can divide out of each. It's sort of like when you're reducing a fraction. You look for the largest number you can divide out of the top and out of the bottom. So it's that same skill when you're reducing a fraction. As far as the variables go, we're going to use the lowest exponent of each of the common variables. Okay? Now, I'm going to run through and I'm going to do the mechanics on 3 problems. And then I'm going to do some problems that we're going to do things that are not the greatest common factor. And when you look at what's left over, it's going to be obvious that, hey, there was more that you could have divided out. So, kind of give you a little bit of the game plan on what we're doing. Okay, the first 2 terms, pick a couple that were pretty straightforward and easy, 18W and 27. So now, the first part is find the greatest common factor of the coefficients, 18 and 27. What's the largest number you can divide out of both? The largest number you can divide out of both is 9. Now some of you may have looked at that and said, well, I can divide a 3 out. Yes, you can divide a 3 out, but we're looking for the largest number. We can divide a 9 out of both of these. Okay? Now, when you look at that, and you might say, how do I know 9 is the largest number? Well, go on ahead and divide it out and look at the leftovers. So divide by 9, divide by 9. 18W divided by 9 is 2W. And 27 divided by 9 is 3. Now these are separated by a comma, so I'm still separating my answer. Well, my answer here is 9. That's the greatest common factor. But I'm just going to look at 2W and 3. Is there anything else I can divide out of 2W and 3? The answer there is no, there is not. 60z to the 4th, 70z to the 8th, 90z to the 9th. Now we've got coefficients and variables. If you look at the problem up above, there was no W on the second one, so I simply ignored the variables. All right, but first the coefficients. What's the biggest number you can divide out of each? And the biggest number you can divide out of each of these is a 10. Yes, you can divide out 2's. Yes, you can divide out 5's. Now there's some people that look at it and say, but you can divide a 30 out of the 60 and the 90. Yes, you can. Can you divide a 30 nicely out of the 70? The answer is no, you cannot. So 10 is the largest number we can divide out of all of those. As far as the variables go, they all have a z, so they have a common variable. Use the lowest exponent. What's the lowest exponent between 4 and 8 and 9? The answer is obviously 4. So it's 10z to the 4th. Okay? Now, again, just a nice little way to look at it and see. What if we divided each of these by 10z to the 4th? This is just a way for you to check. Okay? This is just a way for you to check. Did I divide out the largest thing I could divide out of all of those terms? Well, 60 divided by 10, that's 6. Z to the 4th, z to the 4th, the z's cancel. 70 divided by 10, that's 7. Z to the 8th divided by z to the 4th. Don't forget, when you're dividing, you subtract exponents. So 7z to the 4th. 90 divided by 10, that's 9. Z to the 9th divided by Z to the 4th is Z to the 5th. Now look at this number-wise, 6, 7, and 9. Is there any number you can divide out of all three? The answer is no. Z to the 4th and Z to the 5th, but this doesn't have any Z's that we can divide out, does it? So since these don't have anything else we can divide out, 10Z to the 4th is the greatest common factor. Look at the bottom one, no numbers. I have negative A to the 4th, B to the 5th, A to the 3rd, B. There's no numbers, so there's no numbers that are part of the greatest common factor. Yes, there's a negative 1 there, yes, there's a positive 1 there, but we don't factor out 1s when we're talking about greatest common factor. At least for the coefficients, we don't. So we do have common variables, A to the 4th, A to the 3rd. 3 is smaller than 4, so it's A to the 3rd. And we have B to the 5th and B, oh my. This doesn't have an exponent. Yes, it does. It has an exponent of 1. The 1 is understood. What's smaller, 1 or 5? Of course, 1 is smaller, so it'll be B to the 1st. Do we put 1s on our answers for exponents? No. It's just like the 1s that are in front of variables. They're understood. We don't write them down in our answer. So the greatest common factor here is A to the 3rd B. Okay? If we were to divide both of these by A to the 3rd B, A to the 3rd B, A to the 4th divided by A to the 3rd, that's A. B to the 5th divided by B, now that is B to the 1st, that's going to be B to the 4th, isn't it? Now look at the second one. A to the 3rd divided by A to the 3rd, that cancels. B divided by B, that cancels. When everything cancels, I don't know why I put a comma there. I apologize. I had to put the comma there. When everything cancels, you're left with 1. When you compare AB to the 4th and 1, do they have anything in common? No. You know, there's nothing more that you can divide out.